Well, let's look at this power series centered at 0 and see if we can figure out what the interval of convergence and the radius of convergence is. We know that either this converges at the single point 0, or it converges for all values of x, or there's some value of r so that this series converges between minus r and it diverges for the absolute value of x bigger than r, and we're not so sure what happens at the endpoint of that interval from minus r to r. So the ratio test is the most useful test in this case because we're talking about powers of n, and in this case we also have factorials in our expression for the nth term. So let's use the ratio test to figure out where the series converges or diverges. So let's assume x is fixed. We're not going to specify what it is, but let's assume it's some fixed number for the purposes of this calculation. We're looking at the limit as n goes to infinity of the absolute value of an plus 1 over the absolute value of an, and that's the limit as n goes to infinity of the absolute value of x to the n plus 1 over the absolute value of x to the n times n factorial over n plus 1 factorial. And it's really important to keep the absolute values with our x here. After cancelling the absolute value of x to the n and n factorial, we're looking at the limit as n goes to infinity of the absolute value of x over n plus 1. And since that absolute value of x is some number, we haven't specified what it is, but it doesn't depend on n in any way, we can pull that out of the limit. So this is the absolute value of x times the limit as n goes to infinity of 1 over n plus 1. Now, no matter what the x is, the limit as n goes to infinity of 1 over n plus 1 is 0. So this limit is 0, and it doesn't depend on x in any way. And of course, from the ratio test, the interpretation of that 0 means that our series converges for all values of x, no matter what the value of x is, because this limit is 0, which is less than 1. Our power series converges for every x value in the interval from minus infinity to infinity, and in this case the radius of convergence is infinity, and the interval of convergence is from minus infinity to infinity. Now, in fact, in a few lectures we'll be able to tell what the actual sum of this series is for any x. Surprisingly, this function coincides with one of the functions we looked at earlier in the course.